All right. So let's go over the quiz here first. Now, I know you guys didn't do as well on the quiz as you'd like, but, just learn from when I go over it, and then you'll see, when you see similar questions on a test next week, especially for like number one, make sure you know how to do it now. So let's go over this here. I also posted this on Canvas, so you'll see this. So find dy over dx by implicit differentiation. So x to the 7th, that's just 7x to the 6th. Now, this gave you guys some trouble. 5x times y to the 4th, you got to use the product rule there. So this is first times the derivative of the second plus second times the derivative of the first. And then, of course, the derivative of y is dy over dx. So again, derivative of first, so 5x, that's first. The derivative of, let me just, so this is the first, the derivative of the second. So derivative of y to the 4th is 4y to the 3rd times dy over dx. And then this is second times the derivative of the first. Once you get to this point, then you move the dy over dx's to one side, so I move to the left. Some people decide to move to the right, you'll get an equivalent answer. A couple tips I want to give you guys. When you're writing this out, like this part right here, when you're writing this part out, I notice a couple people, they go like this: 5x times 4y to the 3rd times dy. You spread it out so much like that. It's a multiplication, so keep them close to each other. Because then on the next line, for some reason, this ended up being a plus sign, and then you split these two terms up, and then they're not. It's the same term. It's supposed to be 20 once you multiply it out. And then that's one mistake. The other mistake, it's not a mistake, some people made is they decided to factor the 5 out. That's not a mistake. You could do it that way. So that you thought of it as 5 times bracket xy to the 4th like that. So you're going to leave the 5 factored out and use the product rule on x and the y to the 4th. So you go first times the derivative of the second plus second times the derivative of the first. But then you got to remember the 5 is factored out, and then you got to distribute it on the next step. But some people put a 5 here and another 5 here. So then it was a 25 when it's distributed. There was mistakes like that. So I would say that the best way to do it is to just treat 5x as one item right here. Oops. So you would treat 5x as your first part and y to the 4th is the second part, and use the product rule. Anyway, question number 2 is natural log of something. How do you take the derivative of natural log of something? Well, what you're taking the natural log of goes on the bottom. So that's the sine of x plus e to the 3x. Its derivative goes up top. Well, the derivative of sine of x is cosine of x. Derivative of e to the 3x, remember, is itself times 3, the exponent, the derivative of the exponent. And that was pretty much it. So some of you left that 3 off. All right, you guys, a lot of people don't have their video on. What's going on? Daniel Chacon, I expect better from you.
I missed the class, so I failed.
No. I meant better from you having your video on.
My bad. Oops. That's really bad.
All right. So and let's go over the home. Again, if you didn't do it as well as you'd like on this quiz, this is the wrong class. Make sure, just learn from your mistake. You're going to have a test next week, and the point is work a lot more on the test. So exam is a week from this Thursday. So we'll have an exam, and then you can do well on the exam, and we'll be good. All right, so any questions on the homework? What did we do last time? Last time we did sections 310, 311? Yeah. So questions on 310, from 310. And by the way, this is on Canvas, so you can, the quiz 4 answer key, I put it on Canvas for you. All right. Questions, anyone? So I think next semester, it's pretty much settled. Most classes are going to be online at Fullerton College. But the good news for me, this doesn't apply to you, but Cal State Fullerton is really seriously trying to go back on campus for the fall. I'm excited about that. Contingent on enough people get vaccines, et cetera, et cetera. Sure, I'll believe it when I see it. All right.
Bars are opening too.
Oh, no, I already been going to the bars. So I have places that I go to. I'm just joking, but this is a joke.
Question 13, letter B.
So have any of you heard of the bar called Biggs in Fullerton?
I used to frequent that place quite a bit.
Oh.
I have a couple friends that work there.
Oh, yeah. So, yeah, they're open. They've been open.
YOLO.
So no, because I was talking to the server there, and I go like, you guys don't get in trouble? She goes, sometimes we get a Karen here, and they say, oh, not everyone is wearing their mask properly, and the tables are not 6 feet apart. So they call the police on us. The police come, and they don't want to be here. So they'll just, because the police, the ones that come, they're our customers. So sometimes they come when they're not working. So they don't even want to come here to bug us. So they tell us yeah, just make sure you put your masks on and have the table 6 feet apart. And then once they leave, we put it back to the way we like it. So it's good that the police are on the good side, huh? Okay. If the police were on the bad side, then you get what happens in Iran. Never mind. I'm just going to stop talking.
They have a good happy hour.
Imagine the police actually agreeing with the governor of California and having knocking on people's door, making sure you have no one outside of your family here. Oh my God. So questions on homework? No questions. All right.
I think somebody said 13B.
Yeah, 13B.
Oh, it's not in the chat. It doesn't count.
Sounds good to me.
Did someone say 13B? I didn't hear it. One differential. All right. So by the way, just FYI, if in case I don't want to just spin around, I was actually complimenting police here. FYI, okay. I was not ragging on them. That didn't come across compliment, right? Yeah. Y equals 1 minus b squared divided by 1 plus b squared. So take the differential. So basically, you gotta find the derivative. Once you find the derivative, you just go times dx, and that will be the differential. So you gotta use the formula here. Bottom times the derivative of the top. The derivative of the top is negative 2b minus the top times the derivative of the bottom, which is 2b, all over bottom squared. And this will be times dx. So then you simplify. Remember on the quotient rule, I said simplify the numerator as much as you possibly can, and then you're good. So just FYI, this should be negative 2v here. So we got negative 2v minus 2v to the third. And this is going to be minus 2v as well. So I'm going to put 2v here along with the minus sign. So minus 2v plus 2v to the third all over 1 plus v squared times dx. So then let's see here. The minus 2v to the third plus 2v to the third cancel out. You got negative 4v over 1 plus v squared times dx. All right, does that make sense for 13b? The back looks like by the order, not pretty much the order. All right. So how about number 27 then, before we continue? Use linear approximation or differentials to estimate the given number. E to the 0.1. So you see how this would be a tough problem to do without a calculator. So we're going to use differentials. So we need to call f of x, which would be e to the x. And we're going to let x equal 0, dx be 0.11. How many of you did this problem for homework already? Okay. So those of you who haven't attempted it, go ahead and try your best to do it. Just FYI, you're going to use this. F of x plus delta x can be approximated with f of x plus f of x dx. By the way, we're working on this. If you have a question from a related rate section, I can do one more problem for you today. So just pick a problem. I mean, it's already open on campus. We'll discuss that in class together as well.
Professor?
Yeah.
Dx and delta x are the same thing, right?
Yeah, delta x and dx are always the same, but dy and delta y are not.
Got it. Thanks.
So let's go ahead and do this. So the derivative, of course, is itself. All right, so here we go. So we're going to go f of 0 plus 0.1, which is f of 0.1. can be approximated by f of 1 plus, sorry, the f of 0 plus f prime of 0 times 0.1, right? Okay, so f of 0, that's just e to the 0, plus f prime of 0, that's also e to the 0, times 0.1. So we get e to the 0, which is 1, plus 1 times 0.1, which gets me 1.1. So do you see how, without a calculator, I approximated e to the 0.1. Now, FYI, I'm going to get my calculator out to see what the exact answer is, or closer to the exact answer, I should say. E to the 0.1 on the calculator will give me 1.105170918. So anyway, yeah, 1.1 is a pretty good approximation. You're good to 2 decimal places on this. All right. But here's the thing. On a test, if I said use differentials to approximate, this is what I want to see right here. All of this, actually. I guarantee you there'll be one person who will just give me this. Like, I know you know how to punch in e to the 0.1 on your calculator. That's not what I'm asking you on the question. Lauren, did you get that? Okay, good. Not that I would think Lauren would be the person who would use her calculator to do that. Good. Maybe. All right, moving on. So we're going to do section 4.1 today. And on Thursday, we will do 4.2. And I think that's fine, right? We're going to do 4.3 after the, I don't remember, do I include 4.3 on exam 2? Oh, yeah, do you know if 4.3 should be included on exam 2 or not?
I mean, I don't know. It's up to you, but I'd say 4.2 is good enough. The class will agree.
Okay. I'm going to stay consistent here. Yeah, we're good. Because 4.5 we're not doing, so we could go to 4.3 and 4.4 next week. And then 4.7. Yeah, because the 6.1 I have at the very end, we can always not do that one. Okay, because that's not part of the class. Okay. Yeah, we'll take it easy. Just one section each day for this week. Because we still got to talk about related rates. Oh yeah, you guys think of a related rate question that you want to write? You want me to talk about? You want me to pick one? All right, I'll pick this. How about, let's go to section 3.9, related rates. I will do number 17. So if you have your book, go to page 249. And number 17. Here we go. 2 cars start moving from the same point. One travels south at 60 miles an hour, and the other travels west at 25 miles per hour. At what rate is the distance between the cars increasing 2 hours later? All right, so we draw a picture. So you got one car that's going south at 60 miles an hour. Another car going west at 25 miles an hour. So I don't know why in my answer key I let that be X, this one Y, but we're going to stick with, so stay consistent with my answer key that I put on Canvas for you. So if X is going south, Y is going west, that means dx over dt is going to be 60 because you're going south at 60 miles an hour. Dx over dt is your rate of change. dy over dt is going to be 25. And they're both positive because they're making the line increase, right? X is getting increased as time goes and Y is getting increasing. So eventually, so the distance is that dashed line between them. You see how that, if you're watching a video, they're getting further and further apart. So this distance is their distance. So as time goes on, their distance gets further and further apart, right? So the question is, exactly 2 hours later, how fast is their rate changing between them? So I called it H in the answer key, so I'll call that H. So basically they're asking you 2 hours later, find dH over dt, or whatever letter you decided to call it. So this is going to be a right angle. So in this case, it's pretty obvious that you're going to use the Pythagorean theorem. So you're going to say, all right, h squared equals x squared plus y squared. And take the derivative of both sides with respect to t. 2h times dh over dt equals 2x times dx over dt plus 2y times dy over dt. Now, so when they say 2 hours later, you have to determine what x and y are and h are 2 hours later. Well, if you're going 60 miles an hour, 2 hours later, x equals 120, right? Because you're going 60 miles an hour. So in 2 hours, x is 120. Y will be 50 because that's 2 hours later if you're going 25 miles an hour. So what would h be? Well, h squared equals 120 squared plus 50 squared. And it's actually the 5, 12, 13 triangle. So h ends up being 130. You guys, are you familiar with the 5, 12, 13 triangle? Okay. So anyway, so you're going to plug in the 130, the 50, and the 12, and the 120 into the problem here. So 2 times 130 times dH over dt equals 2 times x, which is 120, times dx over dt, which is 60. Plus 2 times y, which is 50, times dy over dt, which is 25. Anyway, you go ahead and solve for dH over dt, which is, you can do that. You end up getting dH over dt equals 65. So that means 2 hours later, their distance between these two cars is changing at 65 miles per hour. Now, to make it obvious, if they were going exactly opposite directions, like one car is going this way and the other car is going that way. So if this was going 60 miles per hour and this one was going 25 miles per hour, how fast is their rate changing between, the distance between them changing? 85, right? If one is going 60 that way, the other one is going 25 this way, and one is going west, one is going east, no matter what time, if it's 1 hour later, 2 hours later, 3 hours later, their rate is constantly changing at 85 miles per hour. So that wouldn't be a very fun problem because it's just too easy. Whereas this one, well, it depends. At this particular moment, it's changing 65 miles per hour because they're going away from each other, but not like as fast as they could possibly go going away from each other. Does that make sense? Madison, are we good? All right, so that was number 17. And I think I've done number 11 for you already. And 13, we talked about a little bit, I think. So anyway, think of it. Next time you can ask me a question. Again, all right, so starting for section 4.1, maximum and minimum values. So if you have a curve, like on a graph, and let's say you have something that looks like this. This is, again, I'm just a random picture I'm drawing. So always look at a graph going left to right, okay? Like you're reading a book. So this is right now going downhill, right? See where my cursor is at? At that area, it's going downhill because you're thinking left to right. So you're going downhill. And then at that point right there, for a split second, it stops. Then it goes back uphill. Then for a split second, it's not going up or down. It's the tangent line. So like notice here, tangent line is negative, 0 for a split second. Then positive, 0, negative. That's what I was trying to explain. Then it negative, 0 again, positive. And then this is again 0. So notice where the derivative, where the tangent line is 0, we call those critical points. Now, it just happens that critical points, notice, let's say this critical point, notice it's the lowest point in its area. Not the whole function, but in its local area, that we call that a relative or local min. This would be a relative or local max. Now, we're going to talk more about that in a future section, but right now, just focus on it being a critical point. Now, also, let me give you another graph. If you have some graph that looks like that, where it's a sharp turn like that, that's also a critical point. Now, the derivative doesn't exist there. Remember, when you have a sharp point, I may have briefly mentioned that earlier this semester, I may have not, but the derivative doesn't exist at a point like that when it's a sharp point like that. It's got to be a smooth curve where the derivative would be here 0. But anyway, both where the derivative is 0 or where the derivative does not exist, those are both critical points. So let me talk about the definition of a critical value. Critical values occur when the derivative is equal to 0 or when the derivative does not exist. Now, why is it important that we know how to find the critical values? Because once you find the critical values, you can do, there are a lot of things you can do. Like, for example, find out where the local max mins are, and also absolute max and mins, which we'll talk about as well. Now, an absolute max and min it's the maximum point overall in the whole graph, or minimum in the whole graph, or in the interval that you're talking about. So, the relative max means just relatively, and its area, for example, would be the maximum. So if I was talking about this area, this would be a relative max because it's the peak point in its neighborhood. It might not be the peak point overall. Maybe this goes up higher over here on the left side, but in its area, it's the relative max or local max. Some books call relative max, and this book calls it the local max, but it's the same thing. So we're going to talk about relative and local max in a later section in chapter 4, not right now, but I just wanted you to see what it is. The absolute max and min is what we're going to talk about, is how to find the maximum, absolute maximum in an interval. So I'm going to give you an interval, and I'm going to say, hey, what's the highest point? What's the lowest point? Which we'll do that a little bit later. Right now, we're just going to find the critical values. All right, so make sure you know this for now, and then let's do an example. For the next couple questions, what I'm going to do is the directions will be find the critical values. When I say critical or critical numbers, find the critical values. or critical numbers. Sometimes the book will call it. Basically, when they say it worded like that, means just the x value. If I say critical point, then that's a point. You got to give me the x and the y, which is not much more work. You just find, once you find the x value, you plug it back in and you get the y value. So just focus on getting the x value. First question, f of x equals x to the third plus x squared minus x. So critical values occur when the derivative is 0 or does not exist. So what do? You take the derivative. So here's how you would do the problem. I'll do it in blue. So the derivative is 3x squared plus 2x minus 1. Now, this derivative is a polynomial, so it's always going to exist. You really don't have to worry about when the derivative doesn't exist when you have just a simple polynomial. You'll worry about that when you have fractions and stuff. So set it equal to 0 and solve for x. So hopefully this factors. Plus 1, minus 1. Set each factor equal to 0. So the answer, the critical numbers are x equals 1/3 or x equals -1. Those are critical x values. So basically, you take the derivative and you want to know when is the derivative equal to 0. And that would give you a critical value. Now, just because it's a critical number doesn't necessarily mean it's a max or a min. We'll talk about that later. Right now, we're just focusing on finding the critical numbers, which then it could possibly be a relative max or a min, or absolute max and a min, or a min. Just it has a possibility. So, but we have to be able to find the critical numbers first before we can test to see what they are. So let me have you guys do one. Just find the critical numbers. That's all we're practicing right now. All right, you guys try to do this one first. Oh, by the way, no quiz this week. Do you guys want a quiz?
No, thank you.
Don't worry, we'll have another one eventually after the exam. Because next week is the exam, then it's spring break. When you come back, we'll figure it out. Okay, so the derivative is 3 times 1/3 is 1 times x squared minus 6x plus 5. Set it equal to 0. This is a pretty easy one. I got this from my business calculus book. Minus 5 minus 1. So you get x equals 5, x equals 1, right? Those are your critical values. All right, let's do another one. What if we got g of x equals the square root of 1 minus x squared? Again, the same directions. Find the critical numbers. So, well, we're going to change it to the 1/2 power first. Then we're going to take the derivative. So that's 1/2 times 1 minus x squared to the negative 1/2 power, the chain rule, times the derivative of the inside function, which would be negative 2x. So the 2's are going to cancel out here. So then you got negative 1 minus x squared or negative x. 1 minus x squared to the negative 1/2 power. I'm going to drop that to the denominator, and it becomes a radical. Now, you got to remember what I told you. It's when the derivative is 0 or undefined, or when the derivative doesn't exist. So you got to worry about both situations here. The derivative is going to be 0 when the numerator is 0. So f prime will equal 0 at x equals 0, because when the numerator is 0, the whole thing will be 0, right? 0 over any number is 0. But you also have to worry about when the denominator is 0. When the denominator is 0, you can't divide by 0, so the derivative does not exist when the denominator is 0. So you got to worry about the scenario where the denominator is 0. So f prime does not exist when 1 minus x squared is equal to 0, because that would be when the denominator is 0. So that would be, it's got to be, okay, I'm trying to simplify it a little bit, but if I'm oversimplifying it, I'm not telling you everything you're supposed to know. So I hope this doesn't confuse you. It's supposed to be when the denominator is 0, but we don't care about, but it's still got to be in the domain of the original function. So I know I said a lot there. Because if it's not in the domain of the original function, it means that point doesn't even exist. So how can it be a critical number? It's the point, so x equals 0, for example, 1 minus x squared being 0 is okay here. So it is in the, as long as it's 0. But it can't be negative. So what about the cases when 1 minus x squared is negative, because you can't take the square root of a negative? Well, 1 minus x squared, you don't have to worry about it being negative because it's not even in the domain. Did you all catch that? Yeah. So right now, let's just, I know this is new to you, just worry about it being 0 because you can't divide by 0. So 1 equals x squared, square root both sides, plus or minus 1. So if x equals 1, negative 1, or x equals 0, those are, so here's your critical numbers. So that's your final answer. So you basically got to get the collection of x values, the collection of x values that make the derivative 0, and the collection of x values that make the derivative does not exist. You put them together in one pile, and that would be your answer. All right, how are we doing on that?
Where did
All right.
F prime equals 0 come from?
Well, that's when the derivative, when the numerator, I set the numerator equals 0 of the derivative right there. So it's negative x equals 0, which means x equals 0. So that would be negative x equals 0, which implies x equals 0. So just remember, whenever the derivative is a fraction, where the numerator of the fraction equals 0, that's when the derivative is 0. So that's included as a critical number. And when the denominator is 0, that's when the derivative is undefined. So that also gets included. We'll do another one where you get a fraction, so you'll get the hang of it. So if the derivative of a function equals some fraction, let's call it p of x over q of x. When p of x equals 0, then f prime equals 0, right? That means 0 over any, provided it's not 0 over 0, because then that's a whole another mess. But when p of x equals 0, then the derivative is 0. So you include those x values. When q of x equals 0, then f prime does not exist. That's also a critical number. So you got to watch out for both. Because remember the definition of critical numbers, which I wrote right here and highlighted. Critical numbers occur when the derivative is 0 or when the derivative does not exist. So when you have a fraction, you got to watch out for both. All right, let's do another example. F of x equals x minus 1 over x squared plus 4. So in this case, remember the quotient rule, your favorite rule? Go ahead, take the derivative, use the quotient rule. Birthday, how are you doing over there?
Doing fine, Professor.
Okay. I had a question here today. Is your room lit? It's just through the camera. We can't see it very well. So like you yourself, when you're writing, you can see well.
Yeah, I can see pretty well. It's just through the camera.
Oh, okay. Because we're going to take a trip to Home Depot if you need some better lighting. Sorry, it's my time of the day that I got to make fun of you. All right, let's go over this here. Any of you done? By the way, this is going to be a mess. You're going to have to use the quadratic formula, just the FYI. Any of you use the quadratic formula? Madison, what are you laughing about? What happened?
I got to the problem for like the numerator and I couldn't figure out what to do with the equation, and I don't know why I didn't think to use the quadratic formula, but no, I did not use it. I should have, but I didn't think of it.
Oh, so you just said, oh, yeah, because the thing is usually like in my business calculus book, they usually all factor, but they figured, okay, we're dealing with grown-ups in Calc 1, so we're not going to make them all factor. I mean, grown-ups mathematically. Bottom times the derivative of the top, which is 1, minus top times the derivative of the bottom, which is 2x. I'm going to put the 2x over here, all over bottom squared. So let's simplify the numerator. X squared plus 4 minus 2x squared plus 2x all over x squared plus 4 whole quantity squared. The 2x squared and the minus 2x squared right here, they combine to negative x squared plus 2x plus 4 over the x squared plus 4 squared. So that's the derivative. Now, you just really got to worry about the numerator. When is negative x squared plus 2x plus 4 equal to 0? Because the denominator will be quick. I'll tell you. Well, actually, I'll talk about the denominator right now. And when is x squared plus 4 squared equal to 0? So the denominator can never equal 0, because let's just walk through this. Forget about the algebra for a second. If I'm squaring some number, then it's always at least 0, right? If you square something, it can't be negative. Then I add 4 to it. You're at the very minimum now at 4, right? Then I square it. Now I'm at the very minimum at 16. No less than that. So the left side could never be less than 16. So could it ever equal 0? No. So there is no x values here that make x squared plus 4x, x squared plus 4, the whole thing squared, equal 0. So therefore, f prime always exists. Because remember, the denominator, if it's 0, those would be the values that will make the derivative undefined or does not exist. But since the denominator could never be 0, the derivative will always exist. So the derivative will always exist because the denominator could never be 0. But can the derivative ever equal 0? Well, that's where the numerator comes into play. Can the numerator ever equal 0? There, we're going to use the quadratic formula. Now, I don't like my a value being negative, so I'm going to divide everything by -1. That's just my preference. You don't have to do it that way. Then really quickly, I can check that it doesn't factor. So if you try, you can see that two numbers that multiply to a -4, so they got to be opposite signs. 2 and 2, nor 4 and 1 work. So we're going to have to use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Do you remember that? That's the quadratic formula. All right, so x equals. I'm going to use a being 1, b is -2, and c is -4. So -2 plus or minus the square root of b squared. That's -2 squared minus 4ac all over 2a. So don't forget the double negative changes into a plus 16. All right, this does simplify. Radical 20 is 2 rad 5. Right, because 2 times 2 times 5, you can take the 2 out. And then put 2 underneath each one. And we finally get 1 plus or minus radical 5. So your critical numbers are x equals 1 plus radical 5, x equals 1 minus radical 5. That's a long one. No, I will not put this on the quiz this Thursday since we're not having a quiz this Thursday. But be able to do problems like this because, you know, when you go to Math 152, you're going to be expected to know stuff like this just because, like, you know, oh, you have to use the quadratic formula. Don't expect another professor to say, oh, don't worry, I won't put this on the test. Because, you know, you're not always going to have me or Aaliyah to help you.
Professor.
Yeah.
So going back to the x squared plus 4 squared equal to 0, I'm kind of confused with that. For some reason, I thought like you could do x squared plus 4 and then x squared plus 4 equal to 0. And then come up with an x value for that.
Say that again. Why do you think you couldn't?
So for the x squared plus 4 squared equal to 0, no x value?
Yeah, it's because there can't be. Because look, when is x squared plus 4 ever equal to 0? Move the 4 over, -4. X equals plus or minus 2i. There is no real values that make x equal 0.
That's right. All right.
So someone wanted me to scroll up. Is this good or you want further or is that good? Or scroll down. You mean this way, right? Or this way? Well, if I go here, you're seeing the whole thing here. You want to see this? Well, the original beginning of the problem is right here. So that's the beginning of the problem. Go ahead and screenshot that first. Yeah, so yeah, this was a long one. Then rest of it is here. Lauren, the fan looks lovely. Thank you for showing us the ceiling. Omar, very good background. Thank you. Hey, you guys are my best participating class. Like we get almost everybody here, every single classmate. Well, today we got a couple people missing, but usually we get almost everybody here.
Professor, I have a question.
Yes.
So when we couldn't factor out, we went to using the quadratic formula. Is there another formula that we might have to use to answer the question, or is it just that the quadratic formula fit here with the situation?
Oh, quadratic formula will always work. There isn't a time that you can't use the quadratic formula on a quadratic equation.
Okay, that makes sense.
There are other techniques. I don't recommend them, but completing the square, stuff like that. But I would just go factoring, and if it doesn't factor, quadratic formula.
Okay, all right, thank you.
Factoring is easier, but sometimes it doesn't factor. Most of the times it does factor, but I wanted to do this for you guys. All right, I'll do the next one. Same thing, find the critical values. H of x equals the sine of x. Now, the sine of x, if you remember from trig, the graph looks like this, right? So, and it keeps on going forever. So there is, there are critical values. There's an infinite number of them, right? Because it keeps on going forever. So let's just stick with our technique. Take the derivative, which is cosine of x. Set the derivative equal to 0. When is cosine of x equal to 0? Well, let's just worry about from 0 to 2 pi right now. Where is cosine 0? Well, at pi over 2, the 90-degree angle, and also at the 270-degree angle, which is the 3 pi over 2. So far, so good? Now the question didn't just say 0 to 2 pi. If it did, then you would just say pi over 2 and 3 pi over 2. So remember the unit circle. Over here, cosine is 0, and over here, cosine is 0, because that's when the x value is 0. So, but notice, as I'm moving over through the unit circle, it's at 90 degrees, 270 degrees, but if I keep going, add another 180 degrees, add another 180 degrees. Each time I add 180 degrees, I get another critical value, right? Or another, what's 180 degrees in radians? Pi. So if I add pi to it each time, so in reality, if I want to write every single one of them, it's pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, ... Now, how could I write this in terms of a general? So it would be x equals pi over 2 plus
Pi.
n pi. What'd you say, sorry?
Oh, nothing. I was gonna say that. Yeah, never mind.
Because you're adding where n is an integer. So that, and then of course, if you look in the back of the book, they might not write it like this. They might write it something along the lines of x equaling pi over 2 times 2n plus 1. Well, if you simplify it, it's the same thing. I'll show you how to go from here to here. It's a little bit easier. If you were to distribute the pi over 2 here, you would get x equals pi times n plus pi over 2. So they factored out the pi over 2. It's the same thing that I have here on the left side. But it's just so much easier to explain how to get this than what the book has. Because it's pi over 2 that I'm adding the pi to it each time. So that's how I'm going to there. So if they don't ask you to over an interval, that would be that. So if you have a trig function, watch out for that. Anyway, so to generalize what I've done so far is whenever you're asked to find the critical numbers, You got to find the derivative and set the derivative equal to 0. If it's a fraction, worry about when the derivative is undefined as well. Now let's take a break and then we'll do the rest of the section. So come back at 4:28. All right, I am back. All right, let's continue on here with same section 4.1. We're going to talk about the extreme value theorem. It says if